So in today's lesson, we get to everybody's favorite part of learning new functions, which is graphing. I know you're all very excited about this. So a radical function is any function with a variable under the radical. So my example, we've got f of x equals 2 times the cube root of the quantity x minus 8. We're also going to take a look at how to find the domain of a radical function. And that's when the expression under the radical must be non-negative or greater than or equal to 0. So using my example, f of x equals 2 times the cube root of x minus 8, we just take that piece under the radical x minus 8, set it greater than or equal to 0, and then solve for x. So our domain for this function is x is greater than or equal to 8. Now, what I don't understand about this domain is that even for odd roots, which are defined if there's a negative under the radical, for some reason when whoever made up radical functions or discovered them in the first place, they decided that all radical functions would have the same domain, regardless of whether or not it's an even or an odd root. So yes, we can take the cube root of negative 8, it's negative 2. But when you're graphing it, we set the domain greater than or equal to 0. So try not to let that confuse you. I know it is confusing, but what's nice about it is that we don't have to worry about figuring out is the domain all real numbers because it's an odd root, or is it non-negatives only when it's an even root. The domain remains the same regardless of the root. Alright, so the first thing that we need to do, of course, is learn how to graph the parent function. So we have y equals the square root of x, and we're going to figure out its domain and range as well. So for graphing, you can start with a t-table, since we're not really sure what this might look like. Now, knowing that I'm going to be taking the square root of x, I'm not just going to pick any numbers. I'm going to pick nice, perfect squares. So I'm going to start, 0 is a perfect square, so I can start with a 0. 1 is the next perfect square. 4, 9. After that, I'm probably going to get off my graph. So I'll start with those 4. Square root of 0 is 0. Square root of 1 is 1. Now for the definition of the function, we're looking at the positive value only. So again, when you take the square root of 1, it has two possibilities, positive and negative. But if we graphed that, it wouldn't be a function. So the function's range is defined as the positive root only. Square root of 4 is 2, and square root of 9 is 3. Plotting these points, starting at 0, 0, 1, 1, 4, 2, and 9, 3. So when we connect these, they're actually connected with a nice smooth curve. And this function is unique in that it has a distinct starting point. So while I emphasize putting arrows on the ends of your functions, this one only has one arrow. It starts at 0, 0 because our function is not defined for negative x values. So our domain, what's under the radical, is just x greater than or equal to 0. Looking at the graph of the function, the range is the same as well, greater than or equal to 0. Thinking about our y values, we're starting at 0 and we're only looking at the positive roots. So y is greater than or equal to 0 is our range.